This video is section 7.4 of our notes packet, which starts on page 6 of our chapter 7 packet. We're going to be looking at exponential functions and their graphs. We have the equation y equals b to the x, right? B is the base. Our variable x is in the exponent. A function that contains the variable in the exponent is called an exponential function. There's two restrictions on the b value. The b value must be positive, so the base b must be positive. It also cannot equal 1. If b is greater than 1, like a number 2, 5, 9, the function increases. It would be a curve going upward. If the b value is less than 1, now remember, it has to be a positive value, but being positive and also less than 1, that could be like a fraction of 1/2, 2/3, 1/4. So if b is less than 1, the function decreases. And the curve would be decreasing, going downward. We want to graph the equation y equals 2 to the x for all integral values of x greater than or equal to -3 and less than or equal to +3. Integral meaning integers. So we want integers from -3 to +3 for our x values. So let's go to our table here and write down our integers: -3, -2, -1, 0, 1, 2, 3. So we're going to substitute the x values into our equation and get out our y values. So when x is -3, y is 2 to the -3, which now we're doing this by hand. We're not using the calculator yet. We need this practice. 2 to the -3. If I take care of the negative exponent, I would write that as 1/2 to the +3, which is 1/8. Next, x value of -2. 2 to the -2 would be 1/2 to the +2, which is 1/4. To the -1 is going to be 1/2, 1/2. 2 to the 0, anything to the 0 power is 1. 2 to the first, 2, 2 to the second, 4, and 2 to the third, 8. So now let's go over to the grid here and plot these as ordered pairs, meaning an x value of -3 gives us a y value of 1/8, x value of -2, y value of 1/4. So looking from the table, when x is -3, y is 1/8. When x is -2, y is 1/4, about a quarter of the way up to 1. When x is -1, y is 1/2. And I'm plotting 0, 1, 1, 2. When x is 2, y is 4. And when x is 3, y is 8. And now, free-handed, connect those in a nice curve. And whenever we draw a graph, make sure we label it with its equation, y equals 2 to the x. The domain, well, the domain was given to us. Right? The domain is going from, I'm going to use interval notation, -3 to 3. All right. But if our domain wasn't restricted, all right, if our domain wasn't restricted from -3 to +3, this would keep going upward and ever so slightly outward to the right, and this here would keep going outward and downward to left, all right, would keep going. So our domain, I'm just going to draw a double line here. Our domain and range, all right, if we had arrows, if I put arrows here, our domain would be all real numbers, right? The symbol for all real numbers. Now our range for the function that we graphed, well, remember, range is lowest to highest. Our lowest y value is 1/8, our highest is 8. So that would be 1/8, comma 8. But again, if we weren't restricted and we had arrows on the end of our function here, the domain would get ever so, the range or y value would get ever so closely to 0 but not meet it. And you could see that on the calculator if you were to look at the table of values in the the table of values on the calculator. I don't want to bring it in the calculator just now. So the range would be all values of y that are greater than 0, because there's what we call the asymptote. Remember what an asymptote is? It's a vertical or horizontal line that a graph approaches but does not touch or cross. Right? So an asymptote is a vertical or horizontal line that a graph approaches but does not touch or cross. All right, so our asymptote here is the x-axis. Right? This is never going to touch or cross the x-axis. So I'm just going to draw this in with a dotted red line. This is the line y equals 0. All right. Our x-axis has the equation of y equals 0, right? It's a horizontal line, and all horizontal lines are y equals. Okay. So our asymptote is y equals 0. Next, we want to graph y equals 1/2 to the x. So here our b value is less than 1. So that means we go back to when our b value was 2, all right, greater than 1, it's increasing. It's a curve, it's a curve going upward. And now, so let's again fill in the table here. Still the same integers. All right. So -3, -2, -1, 0, 1, 2, and 3. And plugging in our values for x, we have 1/2 to the -3. To take care of the negative, this is a fraction. You're going to invert that fraction. That'd be 2 to the +3, which is 8. 1/2 to the -2. That's going to be 2 to the +2, which is going to be 4. 1/2 to the -1 equals 2. 1/2 to the 0. Anything to the 0 power is 1. 1/2 to the first is 1/2. 1/2 squared is 1/4. And 1/2 raised to the third is 1/8. Now, if you have a different colored pencil or pen, we want to go back to the grid and plot those ordered pairs. And I'm going to use green. So I'm plotting -3, +8. Next, -2, +4. -1, +2, -1, 2, 0, 1, 1, 1/2, 2, 1/4, and 3 1/8. Now connect those points with a nice curve. And don't forget, label the graph with its equation. So this was y equals 1/2 to the x. What is the relationship between the two graphs? Right? Well, one is the reflection of the other over the y-axis. Right? So they are symmetric about the y-axis. You can pause the video if you want and try to fill in the next two before I give you the answer. What is the common point in the two graphs? Well, it's where they intersect. The common point is 0, 1. Why would this be the common point in any graph of y equals b to the x? Well, think about it. The x value is 0, right? If you put 0 in for x, anything raised to the 0 power is 1. I think I'll state that. Anything to the 0 power is 1. Did you know that y equals 1/2 to the x is the same as y equals 2 to the negative x? Why is that? Well, if we take 2 to the negative x, and we take care of the negative exponent and write it using a positive exponent, we would write it as 1/2 to the positive x. Name the transformation that occurs between y equals 2 to the x and y equals 2 to the negative x. Again, we mentioned before, it's a reflection in the y-axis. This is a reflection in the y-axis. The one graph y equals 2 to the x and y equals 1/2 to the x, they're reflections of each other in the y-axis. Next page, on your own. On the coordinate plane below, we want to sketch the graph of y equals 1/4 to the x. Then graph y equals x plus 5 on the same plane. All right, so stop the video and set up your table of values. for y equals 1/4 to the x. And if I look at the grid that I have here, we're certainly not going to start off with -5, but let's just stay with x values close to the origin. All right, so let's go with -2, -1, 0, 1, and 2 for our x values. -2, -1, 0, 1, and 2. All right, so maybe now you want to stop and fill in. So 1/4 to the -2, that's actually going to be taking care of the negative. I'm going to invert the fraction. That's going to be 4 to the second, which is 16. Move that over. 1/4 to -1, that's going to be 4. 1/4 to the 0, 1. 1/4 to the first, 1/4. And 1/4 to the second, 1/16. All right, now let's plot those ordered pairs. Now notice the scale here, the y scale is going up by, jumping up by 4s. All right, so just be careful when you're plotting. So -2 is going to have me up at 16 on the y, x value of -1 at 4, x value of 0, we're at 1, so I should be just a quarter of the way up there. And x value of 1, 1/4, get really small here. All right, connect those points. Label the graph with its equation. And now we want to graph y equals x plus 5. Well, y equals x plus 5 is the equation of what? It's the equation of a line, right? This is going to be a line, and you could plug in some values. You could put it into the calculator, but I know from practice that y equals x plus 5 is the equation of a line that has a y-intercept of 5. So I'm going to start at 5 on the y-axis, mark the point 5, and what's in front of x is 1. It has a slope of 1. So from there, I would go up 1 and over 1, but remember my x scale is going by 1, so I'm going up 1 on the y, but then over 1, so it should be right about here. And what happens is you're going to need some more points, but I'll say cheat and look at the calculator. Look at your table of values on the calculator. So you have this line. You get this line. Y equals x plus 5. Find the value of x which would satisfy 1/4 to the x equals x plus 5. Well, in other words, you're looking for the point of intersection. The point of intersection of these two graphs is -1, 4. That's the point of intersection. We want just the x value, which was -1. So the answer to this is -1. Does that make sense? Well, check it. All right. 1/4 raised to the -1. Well, 1/4 to the raised to the -1 is here. We know it equals 4. And if I plug in -1 on the right side, -1 plus 5 is 4. Okay, next on your own, we want to graph y equals 2 to the x, y equals 3 to the x, and y equals 4 to the x on the same set of axes below. Again, take note of this, the numbers on the x scale and the y scale. And I'm going to use 3 different colors. And it might be helpful if you had at home if you use the same. Okay, y equals 2 to the x. to do this, I'm plugging in an x value of, going right here, if I put -2 in for x, right, and y equals 2 to the x, I put -2 in there, and that's going to be equivalent to 1 over 2 squared, which is 1/4. So at x value of -2, really small down there at 1/4. If I put -1 in, that's going to give me 1/2. If I put 0 in for x, well, 2 to the 0 is 1. Now, this is 4 here, so 1's going to be only a quarter of the way up. If I put 1 in for x, well, 2 to the first is 2, so that'll be halfway. If I put 3 in for x, well, I said 3, but I meant 2, so let me go back. If I put 2 in for x, I'm going to be 4. Put 3 in for the value of x there, 2 to the third is 8, so I'm jumping up to 8. If I put 4 in for x, 2 to the fourth is 16. 5 in for x, 2 to the fifth is 32. And 6 in for x, that's going to be 64. Let's just try very gently connect these and label. Put an arrow at the end there. This is y equals 2 to the x. Next, I'm going to use green for y equals 3 to the x. All right. I'm going to start at -1. 3 to the -1 is going to be 1/3. 3 to the 0 is 1. 3 to the first is 3. 3 to the second is 9. 3 to the third is 27. 3 to the fourth is 81, which that takes us off. Okay. Connect these. Okay, so connecting these, give it a nice curve. Oops, I missed a point down there. Please don't you do the same. Let me take off. Gotta get up to, just do that. Label it with its equation, y equals 3 to the x. And now finally, y equals 4 to the x. And I'm going to use red pencil for that, or red pen. So we're looking at y equals 4 to the x. And if I put -1 in there, that's going to be 1/4, which is still really small down there. If I put 0 in, 4 to the 0 is 1. Put in 1. 4 to the first is 4. Put 2 in for x. 4 to the second, or 4 squared, is 16. 3 in for x. 4 to the third is 64. Well, that was quick and easy. Short and simple there. Connect these. And label it. Y equals 4 to the x. Let's note the domain and range for each. Well, again, these are continuous. So the domain keeps going outward to the left. These keep going upward and outward to the right, so that our domain is all real numbers. write the symbol for all real numbers, or you can write interval notation, right? Negative infinity to positive infinity. The range, all of our y values are greater than 0. So y is greater than 0. Or interval notation would be parentheses 0, comma, infinity, parentheses. And the asymptote, again, the x-axis, and the equation of the x-axis is y equals 0. That is our horizontal asymptote. Compare them. Let's just list a few things. Well, they all have the common point 0, 1. Common point to all is 0, 1. Common point to all is 0, 1. Because anything raised to the 0 power is going to be 1. What do we notice about the b value? The larger the base, the steeper the graph. The larger the b value, the steeper the graph. And these are all increasing. They're all increasing, as they should be, because our b values are greater than 1. Okay, and we're done with section 7.4.